Hello, my name is Kaushal. I'm working in data science field for a few years now. Recently, I came across this hackathon by ArangoDB, and I found it very interesting because I already had an idea in mind that I wanted to build with Graph plus AI. So I found this hackathon particularly interesting for the use case, and again ArangoDB was something unknown to me, so I thought it would be a good opportunity for me to explore in this. So this is my submission for ArangoDB hackathon. So for this the application that I've built, I'm calling it as a ForwardSentry. So the core idea is to trace the flow of the forwarded message and transactions. So although this application is not limited to that domain, anywhere where the graph type of data is involved, information moving from one node to another, this application can be utilized. So for now, I'm mainly focusing on message forwarding and fake news detection. So I'm utilizing multiple features of ArangoDB for that. But again, this has an application in finance sector as well. So moving on, the problem statement that I'm working with is this, that for example, in the WhatsApp, we forward the message and we can see on top that this message was forwarded, and if it's forwarded multiple times, then it shows forwarded many times. Now here we don't know who was the original creator of the message. We just know who forwarded to us, right? So this is an attempt here to track who was the original sender and to whom this message was forwarded in multi-hop traversal kind of thing. So and then I'm also utilizing the search functionality to find similar message. So in case of fake news, we wanted to identify who is the person who is spreading this fake news, and we can traverse to the source and we can verify who else is also spreading this kind of false information by utilizing the embeddings of the by creating embedding and storing in ArangoDB and utilizing the vector search functionality. So again, it has the this is one of the application, but it has also application in the financial domain, like in the money laundering, for example, where how money is flowing from one person to another. We can traverse back to the source, and if we can track that as well. It also has an application in LinkedIn as well. Sometimes we see that people copy each other's paste without giving them credits. So using the vector similarity functionality of ArangoDB, we can find the similar post by content, and using the timestamp we can identify that who posted this post first and who copied later on. In terms of tools, again for the ArangoDB, all the data is in graph format, and I'm also utilizing the embeddings. I'm storing the embeddings and then doing embedding search using the ArangoDB. Orchestration is by LangChain, and I'm using the OpenAI GPT-4o model. And also I've introduced one functionality of identifying fake news, so particular message is fake or not. So I'm using SERP API to kind of check over the web whether this message is fake or not. All right, this is the introduction. For this is how so I've created a sample database of my own. This is a synthetic data that I'm just showing here on the ArangoDB visualization in the graph tab here. So here we have various users, various messages flowing from one user to another. So yeah, so we can see that this person is sending to this person, and again the message is being forwarded within. So this is how the overall graph structure looks like, and I'll move on to the notebook here. So this is the notebook. This is very straightforward import statements here, and then we have the config file. So I'm storing all the credentials here, and for the embeddings I'm using Hugging Face model to create the embeddings, and later I will store it in the ArangoDB. So client connection, database creation, and then I'm creating here the various nodes and edges of the graph. So I have mainly users and messages as a node, and messages being sent. So who sends the first message, so this maintains that, and the another edge on forwarded, so who forwards to who and which message. So I have a sample data here on users. I'm importing that. Again, we are creating a vector index using the AQL here, and then we are adding this sample data. So I have 3 sample data sample messages that I'm creating an embedding of the Hugging Face model, and then I'm storing that embeddings in the ArangoDB for future retrieval. So I have these 3 sample messages here, and this is the sent data, who connection on which user sent which message first, and this is how the forwarded data edge look like, from, to, message ID, and timestamp. So this was the data, and this is where our graph gets created, and that we can basically see here. We can visualize our graph from the this is my database here, so we can visualize the graph here. So this is where the graph, and I'm just running a simple query to check. So I'm doing a 3-hop traversal here, that starting from user 1, that message was sent to how many people. So user 1 sent the message to a guy Bob. User 2 is Bob. Then Bob sends to Charlie, and Charlie sends to David. So this is a 3-hop traversal of the same message being forwarded. And then here we have the agentic app. There's a graph, OpenAI. I'm maintaining a config dictionary where all the credentials are mentioned. So I have 3 tools here. First tool is the text to AQL to text. On the simple using this LangChain class, Arango QA chain. Basically it translates the natural query to AQL, executes the query, and translates back to natural language. So I've added 3 simple example query for model to understand better. So rest of the thing. Then I have this is my second function on semantic search. Second tool which performs the semantic search on the messages and returns the cosine similarity. So this is the query. I'm using the embeddings here, and we are doing the embeddings so that we can also see by going to collections, messages, and content, and here you can see that this is the embedding numbers of that message. So it gets mapped, and then we get the embedding. And I have another tool using the SERP API to verify the fact by searching the web whether it's true or not. It's for the fake news. This is a tool for that. Then everything gets put together. Again, we have this object query graph. So this is our first queries. So we have the query find who Alice forwarded message to, and that person forwarded to who. So we are trying to find the hops. So the model writes the query here. So we get the results here that Alice forwarded message to user 2, and that was forwarded again to user 3 and 4 that we saw earlier. So this query is correct. Then we are writing a query that find who forwarded message to Alice. So there's one person, user 5, who only sent a message to Alice. So we also get to know that. And then this was the traversal, and now we are doing a similarity here. So the queries find out the similar message sent by different people along with their name. So we have the result here, where it says that there are two similar messages from the Alice and Bob. They both are talking about the Trump and the election. Similarity scores are here. Regarding so message summarized what it is, and then we are doing the web search tool. So the queries fetch the content of the message one and verify this message by searching web if it's true. So the message one is this breaking news. So first it fetches the message one by executing the AQL, and then that message goes to the tool that verifies the content from the web. Here it says that a web search indicates that this statement is not true according to article, and you can read it more from here. So these are the main few things that I wanted to discuss, and this is my attempt to ArangoDB Hackathon. Thank you.